Hey Techno Studs! Now that we're a little more familiar with wildcard masks, let's take a look at those network statements. So this video is going to cover network statements in OSPF. This is the network that we're working with. I have a switch here, which is a layer 3 switch, and 3 routers, router 1, 2, and 3. I'm consoled into router 1 because what we're going to do here is actually going to break connectivity, so I'm going to console into it rather than SSH into it. Down here, I'm pinging 10.2.0.5, which is this far switch right here, and I'm also pinging 10.240.0.2, which is the interface right here. So what I'm going to do is I'm going to play around with some different network statements. All of these layer 3 devices have OSPF running, and they're using this network 10.0.0.0, 0.255.255.255 area 0. So that network statement includes all of my networks in here, which includes all of the interfaces of these layer 3 devices. So that gives it full connectivity. But let's cut that. And so I'm going to get into the global actually, let's do a show IP route just to take a look at, you can see it's learning quite a few routes here, but I'm going to get into the global configuration mode, and I'm going to get into the router OSPF 10, and I'm going to do a no on this statement right here. So I'll copy that, I'll paste it into here, and there we have it. So now what we can do is do show IP route, and we no longer have those OSPF connectivities. The OSPF still has this process ID of 10, but it's not communicating out any of these interfaces, and so now we've lost connectivity everywhere. So what I'm going to do next is going to do a different network statement. So the network statement I'm going to do is for the interface 10.0, excuse me, it's 240.0.0 is the interface. So we can see between HQ and R1, that is the network right there. And I'm going to do an wildcard mask of 0.0.0. And then we got to figure out what the last part of this is. I do have the answer over here, but what this is a /28 here. And we can see that right here. This network is a 10.240.2.0/28. So if we were going to take the network mask out, we would have 28 ones, which would leave us 4 zeros. And then what we do is we translate that into a wildcard mask, which would be the flip of that. So this is the wildcard mask right here. And that equates to 0.0.0. And then I got to figure this out. Here's the 8 is turned on, plus the 4, so that's 12, plus the 2, which is 14, plus the 1, which is 15. So that would be .15. So I'm going to enter .15 in there, and then area 0. So what we're turning on here is this interface right here. So messages will be sent out now to switch 1, which is going to give us connectivity between R1 and this switch, but it's not going to give us connectivity to the rest of this network. So let's see that play out in action. Remember this ping right here, 10.240.0.2. So that comes live, but this 10.2.0.5 is not coming live because we do not have anything running between this router and the rest of the network. So it's not aware of this last network over here. All right, so next let's get this interface up and running and configure that one. So I can do network and 10.240, and that network is 2, and the IP address of that is right here, is .2. So this time, rather than doing that whole network, I'm just going to do 10.240.2.2. So just the interface. And when I specify just an interface, just a single host, then the wildcard mask is going to be all zeros because there's no variable bits in there. So, and I'll put that as area 0, and I'm going to hit enter for that. And I'll do I'm going to take a look at my IP route here, and I can see it's already populated with more networks. These are the networks from this switch, so that was there before, but the one that we're looking for is this one right here, 10.2.0.0/24. That's the far end. So now I'm pinging that far end here. I got full connectivity throughout my network. So I could either specify the network that these are part of, the whole network, the big scope of the 10.0.0.0, or the specific interface. There is one other command that I'm going to show you, and to do that, I'm going to take this command back off. That's for this interface associated with 10.240.2.2. So that's the interface right there. So far we've been using network statements. The big network statement, the actual subnet that we were working with, and the specific interface. But now what I'm going to do is I'm actually going to get into the interface, and we're going to change the interface. So I'm going to get into interface, and this is serial 000, as I believe what the interface is. And doesn't like that. So let's do show IP interface brief and just see what the interface is. So serial 010. Okay, so that's the interface right there. So I'm going to get into interface serial 010, and then we are going to then specify the command IP OSPF and the OSPF process. So we're using the OSPF process of 10 and the area. And so far we just have one area, and the recommendation for that is to be 0. So we can do area 0, and then we hit enter right there. So now what we've turned off the network statement. Let me pull up my picture here. We've turned off the network statement or the interface statement for this right here, and then we got onto the interface and created that OSPF 10 area 0 there. And we can see that it's just come live here. So we are good to go. We are now communicating across. It is sending and receiving these OSPF packets out this interface. So there you have it. We can use network statements or this interface statement to specify which interfaces we want to participate in OSPF. With the network statement, we can do a really broad statement as long as it includes that interface. We could do just the subnet that interface is a part of, or we could do the specific IP address for that interface. So a few different options when we're configuring OSPF.